Hello, this is lesson 11-7 on page 799 in your book. This is the last lesson we will do for the school year, which is super exciting. And we are going to be covering circles in the coordinate plane. So let's get started. If you will read along with me in your book, the equation of a circle is based on the distance formula that you've learned and the fact that all points on a circle are equidistant from the center. And you know that. That's the definition of radius, all points that are equidistant from the center of the circle. And we're going to start by looking at this graph. We have, of course, the y-axis, the x-axis. We have our circle. We have one radius, but of course there's an infinite number of radii that can extend from the center to the edge of the circle. But we only need one of them, any one of them, to do the equation of a circle. So I want you to notice here that x and y represent a point that is on the circle. I also want you to notice that h and k represent the center of the circle. So h is the x-coordinate for the center of the circle, and k is the y-coordinate. So we use our traditional x and y for points on the circle, and we use h and k to represent the center of the circle. That's super important, so make sure you've understood what I'm saying. And now let's move on to look at the distance formula. This is just review. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. We learned that probably within the first month or two of school, I think. And what we're going to be doing is the distance formula, except that we're going to be labeling the parts of it a little bit different. So if you'll notice that in our distance formula, the distance equals d, or is labeled d, but in our equation of a circle, we substitute radius as that distance. And we use our x and y from the coordinate that were given on the circle, and we use our h and k to represent the coordinate that is the center of the circle. So we say r equals the square root of x minus h squared. That would be this x on the circle minus the coordinate h in the center of the circle squared right here, plus this y, whatever the y is there. So we would have gone over for the x and up for the y. So whatever that y point is, the y in the point is, minus k, which is the y in this coordinate that is the center of the circle. You'll understand this a little bit better as we begin to apply it in our examples. But we also square the y minus k. Now, the next way to write this is to write it without the square root sign. In order to get rid of the square root sign, we're going to need to square both sides. That means we square the radius, so we have radius squared, and we square all that's in here, which means we get rid of the square root sign. Just like saying the square root of 2 times the square root of 2 is the square root of 4, which equals 2. Remember, square root of 2 times square root of 2 equals square root of 4. Square root of 4 is 2. So by multiplying the square root of something by the square root of itself again gives us that number without the square root sign. Same thing here. When we multiply all of this times itself, we get rid of the square root sign. But since we did that, we also had to square the radius. So here is the equation of a circle. It's r squared equals x minus h squared plus y minus k squared, except that you will often see the r squared on the other side of the equation, as you do right here in theorem 11-7-1. So we have x minus h squared plus y minus k squared equals r squared. And what the equation of a circle theorem tells us is the equation of a circle with center h and k, remember that's just simply the x and y coordinate of where that center point is, except we call it h and k, and the radius r. So let's move on and try to apply what we've just learned. Example 1, writing the equation of a circle. We want our final form to look like this. So remember that or keep looking at it as we apply. What we are told in example 1A is that we're dealing with circle A. Remember, this is how we label a circle. Circle A with the center point A, and its coordinates, or its H and K, are 4 and -2. And we have a radius of 3. So let's start plugging those pieces into the puzzle, or into the equation. We have our equation, x minus h squared plus y minus k squared equals radius squared. So now we do not have an x and a y coordinate on the edge of the circle like this. We only have our center point and our radius. So let's come back down. So that's all that we can put in here. We're going to say x minus h was 4, so x minus 4 squared plus y minus k is -2, so y minus -2 squared equals, we were told our radius is 3, so equals 3 squared. Now I want you to recognize right here, we did this earlier in the year when dealing with the distance formula. When we say minus a negative number, of course it's going to become a plus or a positive number, so that's why y minus -2 becomes y plus 2. I think you may have a question on your test that asks you something like that, where honestly I cannot remember what the question asks, but whatever it is, you need to recognize that if this is a positive number in the equation of a circle, that it was initially a negative number in the HK coordinate in the center of the circle, because the only way we can get a positive here is that we subtracted a negative first. So make sure you understand that and ask me about it if you don't. But our final equation is x minus 4 squared, there's nothing we can do to simplify that, plus y plus 2 squared, nothing we can do to simplify that, equals 9, which is 3 squared. And this is the form that we want the final equation of a circle in. Even when we know what x and y are, as you'll see in other examples, we still, for the final equation, will only put in the h, the k, and the radius. And we will leave the variables x and y. Okay, let's look at example B. This time we have circle B that passes through -2 and 6. That would be the xy coordinate somewhere on the circumference of the circle. And we have a center of -6 and 3. That's our H and K. That's our center of the circle. So we're going to start putting these pieces into the puzzle. We do not have a radius this time, but we're going to have enough information to figure out the radius and then to put all of the information into the appropriate form of the equation of a circle without using x and y, but definitely using the radius. The x and y will help us discover the radius. So this time we can either start with this version of the formula, or we can start right here and not have the r squared and keep the square root sign, which is how they started, obviously. So we're going to substitute. This is going to be x minus h. So we have x is -2 right there. H, of course, because it's the center of the circle, is -6. So we're going to have y minus -6, or I'm sorry, not y. -2 minus -6, or -2 plus 6 squared, plus, and here we're going to have y minus k, because that's what the equation says right there, y minus k squared. So our y is 6, it's a point on the edge of the circle, minus the center point k, 6 minus 3 squared. And what that comes out to be is radical 25. So we had this plus this equaled 16 plus 9, which is the square root of 25. All of this should have had a square root sign over it, except for I was just treating it as scratch work and running through it. So r equals the square root of 25, which of course equals 5. Now we know what our radius is. Now we can put this back into, or actually go ahead and put it into the actual form of the equation of a circle. So we're going to put r squared on the right side. Let me write it under here, and you may not be able to see it for a second. Let's see. So we're going to have our equation of a circle is going to say x minus h squared plus y minus k squared. And I would encourage you to write that over and over, equals radius squared, because that's how you're going to learn it. So here's our x. We're going to leave x in the final form and not substitute it. And then we had -6 for our h. So it's going to be x minus -6 squared. And then same with y, we're going to leave y in the final equation minus, and our y was a 3. So y minus 3 squared equals our radius squared. The only thing in this that we can simplify, actually there are two things, is our minus a negative. So we're going to say x plus 6 squared plus y minus 3 squared equals, and we're going to simplify 5 squared so that it becomes 25. And that is the final form of the equation of that circle. All right, let's do one more. Boy, this is a long video. I apologize. But I'm going to keep going because this is the check it out that goes with what we were just doing. So write the equation of a circle. This one I'm going to go through much more quickly. We have the center point and the radius. So we can start it this way, or we can start it by saying r squared equals all of this without the square root sign. But I have r, which is 8 squared, equals x minus 0, because h is 0, it's the center of the circle, squared, plus y plus 3 squared. That was really y minus k, or y minus -3. That's how I got y plus 3 squared. Now we have 64, and obviously this 0 is not going to change this x. So x minus 0 squared is just x squared. So we'll get rid of the 0 there. So 64 equals x squared plus y plus 3 squared equals the 64. We'll put it on the right side. That's the final form of the equation of the circle there. And let's look at the last one. This is like our second example that we did where we do not have the radius, but we have our xy coordinate on the edge of the circle, and we have our center point, our h and k coordinate, which is 2 and -1. So I said r equals the square root, and here's the formula. And again, I could have said r squared equals the formula without the square root. Either way would have solved it. R equals 2, which is our x, minus 2, which is our h, squared, plus 3 minus -1, or 3 plus 1 squared. That answer comes out to be r equals the square root of 16, which we know is 4. So now I'm going to plug it into the actual equation of a circle. I'm going to put my r squared on the right side right here. And I'm not going to plug in my x and y. I'm going to say x minus 2, that's substituting our h, squared, plus y plus 1 squared, that's plus 1 again because this is -1 or -1, so it was y minus -1. Y plus 1 squared equals 16, and that is the final form of that equation of a circle. Okay, I will end the video there. I'm so sorry that it's 13 minutes, and we just have one section left to do, which will be our second video.